This is question number 4 from Intermediate Board Examination, Karachi. And here the two things are discussed. Number one, state the Hund's rule, write electron configuration of the following. So first we have to write the definition of Hund's rule. So Hund's rule, according to Hund's rule, electrons, if there are degenerated orbitals, then electrons are filled in a way that they have maximum number of unpaired electrons. Okay, so we should write in degenerated orbitals, p orbital, p subshell has 3 degenerate orbital. Degenerate means orbitals having same energy. So if the orbitals belong to p subshell, d subshell, and f subshell, they have p has p subshell has 3 orbitals, and all the 3 have same energy. So there are 3 degenerate orbitals. D has 5 orbitals, and all of them have same energy. F has 7 orbitals, and all of them have same energy. So in degenerate orbitals, electrons are distributed in a way that they have maximum number of unpaired electrons, or in other words, maximum number of half-filled orbitals. If there would be maximum number of unpaired electrons, it means the same thing. These orbitals would be half-filled, are obtained. So we can give an example of that one as well. It is better to give example if there is a space in your answer script. So nitrogen has atomic number 7. So it can be written as 1s2, 2s2, and if you write p in separate orbitals, p subshell has 2px orbital, 2py orbital, and 2pz orbitals. So the remaining 3 electrons should be accommodated like this. One point is that there must be 1 electron in each one. And secondly, they must have the same spin. So if spin is up for all, it means they all have the same spin. So it is the correct one. But if you write it like this, 1s2, 2s2, 2px, 2py, 2pz, you have paired before filling all the degenerate orbitals. So this is wrong. But one more thing, then if you write it like this, 1s2, 2s2, 2px, but spin is down, 2py spin is down, and 2pz spin is down. It is also correct. because they all have the same spin. Not necessary that a spin is uh, up spin. Okay, there could be the down spin, but all of them must have the same spin. See one more example: 1s2, 2s2, 2px, 2py, 2pz. See, although they have maximum number of or half-filled orbitals and maximum number of unpaired electrons, but this is wrong one because spin of electron in two orbital is up and for one of them is down. So this is wrong. So Hund's rule not only says about that there should be maximum number of unpaired electrons, but it also tells about that their spin must be same. Next part, where we have to write the electronic configuration of these elements. So now first, chromium, its atomic number is given. I suggest you try to memorize atomic number up to 40, but in most of the cases, atomic number is given in your question. So atomic number is 24. You know, the orbital electronic configuration is 1s2, 2s2, 2p6, and after 2p, 1s2, 2s2, 2p6, 3s2, 3p6. But the next element that is to be filled is not 3d, although 3d is there, but according to n plus l rule, energy of 4s is lesser, so it will be first. It will be filled first. Then how many electrons are remaining? 10 plus 10, 20, 20. So 4 electrons are remaining there. Okay, although it looks correct, but in case if there is a chance that one electron can jump to the from 4s to 3d and 3d becomes d5, then remember that half filled and completely filled orbitals are stable. So the element prefer stable electronic configuration. So this is not correct due to this one. This is the case only in chromium and copper. So the correct electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and one electron jump from here to here. So it becomes 4s1, 3d5. This is the correct one. So in examination, we should write this. Actually, there was a typographical error. This is not SR minus 1, it is SR plus plus. So if there is SR plus plus, then okay. So actually this SR plus plus means these are the SR2 plus ions. Okay. And as many, as much charge is there, so as many electrons should be subtracted from this atomic number. So 38 minus 2, there would be 36. So instead of performing electronic configuration of 38 electrons, we should perform the electronic configuration of 36 only. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p6. After 3d, 4p is filled. Okay, so see how many electrons are there. 10 and 10, 20, 20 and 10, 30, 30 and 6, 36. If there was no charge, then there would be 5s2. But as there is 2 plus charge, so actually those 2 electrons are removed from the outermost shell. Remember that electrons are always removed from the outermost shell, whether it is filled first or later on. For example, in case of chromium, the first electron that would be removed from 4s, not 3d, not from 3d. Okay, so as we have only the plus 2 ions, so we will write up to this electronic configuration. Now see another one is sulfur minus minus. So contrarily, as in case of strontium, we have subtracted 2 electrons because the charge was 2 plus. Charge 2 plus means it has lost its 2 electrons, it has removed 2 electrons from its atom. But if the mass is minus minus, it means it is 2 minus. So from its atomic number, we add 2 more electrons because charge is minus. Minus means it gained 2 electrons. So we will write the electronic configuration of 18 elements, 18 electrons instead of the 16. So it should be 1s2, 2s2, 2p6, 3s2, 3p6. If suppose there was no charge, then the electronic configuration would be 3p4. But here the minus 2 charge shows that it has 2 more electrons. So there should be 3p6. So now you can see in this question, the first part was to write down the definition of Hund's rule. It was not necessary to give the example, just definition was enough. And we are to write electronic configuration of these element and ions. Their atomic number is given. So we should know the correct rule, and any variation or deviation in electronic configuration of some element, for example, in chromium and copper. So that was the question for 4 marks, 1 mark for each electronic configuration and 1 mark for the correct definition. Although example has no marks.